Hey, welcome back to my YouTube channel. I am Xavier Smith, and today I'm going to talk about bearing and navigation. So let's get into it. First of all, our bearing is going to be on like the coordinate compass, which is north, east, south, and west. It's a little different than when we're using like a circle and we're like, oh, well, if you're like on the normal line, you're like 0, and then there's pi, which is 180. We don't do that. So we say north is 0 degrees, east is 90 degrees, south is 180 degrees, and west is 270 degrees. So you'll see on this next example. Well, never mind. So what you say for the coordinate compass is you'll say you could just say like a bearing of 180 degrees, and that means south, right? Or you might hear like north 70 east. And what does that mean? Well, we start at the north-south line. And then we're just like, okay, if it's north 70 east, you go north and then you go 70 degrees towards east. So you'll end up like here. There will be like a 20-degree angle there, which will be useful in your triangles and your problems. So you'll say like south 20 west. You go 20 degrees over west, and that angle right there is 20 degrees. So you have south 20 degrees west. Okay, so let's get into some examples. Remember, it's north and then east, or north and then west. That's why you hear northeast. You don't hear west north. It's not a thing. You start at the north-south line, and if you say south 20 degrees east, well, you start at south, and then you go 20 degrees over to the east. All right, cool. And if you're like, you don't say like north 91 degrees east, right? Because then you're going past like this, and you're in the south boundary. Then you just say south 89 degrees east. Okay, so some examples. If we have 40 degrees right here, it's coming off the north angle, right? This would be northeast, clearly. And since it's connected to north, it's north 40 degrees east. So north 40 degrees east. And then also, if you're going to find like this angle right here, it'd be 50 degrees because this angle plus this angle is 90 degrees. So if you get like just this angle and it says 50 degrees and it says, okay, what's the bearing? Like you have a triangle and you have this angle right here and it's saying, what's the bearing? Well, you're going to do 90 degrees minus this angle and it'll give you 40 degrees. And you're like, okay, so the bearing's north 40 degrees east. Because remember, we're always going from the north-south line and then over. Okay, next example is down here at south. It's 10 degrees coming off south going west. So it's south 10 degrees west. Okay, now draw north 70 degrees east. Well, we'll start north, clearly. We know north, we're going east. Now just guess what 70 degrees is. This is the same thing as drawing like a 20-degree angle, like this. Because that would be 20 degrees, and then just label this 70 degrees, and clearly that would be like a 20-degree angle. Okay, now draw a bearing of 280 degrees. Now is where you'd have to say, okay, well, I know like north is 0 degrees and 360 degrees, and south is 180 degrees, right? So from south to west, it can be anything from 180 to like 200, well, 180 to 270 degrees, right? Once it gets past 270, it starts becoming north territory. So let's look, it's 280. So since it's past like the little west boundary, it's going to be northwest something. Okay, so let's see. This is 270, right? And if we're doing 280, that's just another 10 degrees, right? So we know this is 10 degrees. Now, you just have to do 90 minus 10 to get like 80 degrees. And then your answer is north 80 degrees west because it comes 80 degrees off the north, like the north line, going over west. Okay, so let's get an example in with a right triangle and then do an example without a right triangle. All right. So our example, an airplane flies 120 kilometers on a bearing of 30 degrees or north 30 degrees east, and then turns and flies 160 kilometers on a bearing of 120 degrees or south 60 degrees east. How far from the starting point is the airplane? And what is the bearing from the starting point to the airplane's current position. So let's just start with a classic northeast, southwest. So we got north, east, south, west, right? We are going northeast 30 degrees for 160. So this would be a 30-degree angle, right? And we say that's 160, like km, right? And then we decide to turn and fly 160 kilometers on a bearing of south 60 east, which if you go 60 degrees off of this, it'll be like this. But we can see that 30 degrees, this is why I gave you like the little 30 degrees and 120 degrees. You can see they're 90 degrees apart. So it makes a right angle. So it's just going to be this right angle, right? And then that is, oh, sorry, that's 120 kilometers. And then this is 160 kilometers, right? And then if you want to finish the triangle, you would just connect them. Okay, so what this is asking for is, like, first of all, how far from the starting point is this, right? So we just have x here, like this side, the missing side is x. So let me grab a calculator. So we're going to do the Pythagorean theorem, which is a squared plus b squared equals c squared. X here is the hypotenuse, so it's our c squared. So we will do 120 squared plus 160 squared equals, so c squared equals 40,000. Now, just take the root of 40,000, and you'll get 200. So x equals 200 kilometers. An easy way to check this is that the biggest side should be opposite the biggest angle. While 90 degrees is clearly the biggest angle a triangle can have. Like if you have 90 degrees, you can't have a bigger angle in there. So, like, x has to be the biggest side. Well, the hypotenuse is always the biggest side in a right triangle. 160, 120, clearly x as 200 is biggest. So that we can check and is right. Okay, now what is the bearing from the starting point, from the start point, to the airplane's current position? So if we did like little airplane, which I probably should have done earlier, you know, something like, I don't know. We're just going to do that, right? That's our little airplane, right? And then this is our starting point. What is the bearing from the starting point to the airplane's current position? So clearly we are asking for this little angle in here, theta, right? Okay, so let's get theta. Well, theta, if we look, we have 160 and 120. We could say the tangent of theta equals 160 over 120, right? And that means theta equals tan negative 1, 160 over 120. So I'll just do tan negative 1 of 160 over 120 equals 53.1 degrees. Theta equals 53.1 degrees. Now that we have the angle of theta, we're going to say, okay, so theta equals 53.1 degrees. So what the bearing means, of course, is like the north to this line, right? Because this line is really the angle. So we're not going to say it's just 53.1 degrees because there's still this 30 degrees here. So if we add them together, right, then we'll get all the way from this north line over to the end of the angle. So 30 plus 53.1 is 83.1 degrees. And then don't forget that we have to put like our north and our east. So it'll be north 83.1 degrees east. Now for practice with a non-right triangle. Okay, a ship travels 60 miles on a bearing of 70 degrees, which is north 70 degrees east. It then changes course and travels 80 miles on a bearing of 140 degrees, south 40 degrees east. How far from the starting point is the ship, and what is the bearing of the ship from the starting point. Okay, so we'll say this is a starting point, right? And then here's its north, east, south, west, right? So we're going to travel 60 miles on north 70 degrees. So we move 70 degrees. We're like, okay, that looks like 70 degrees, right? And we're saying we're going 60 mi. Okay, then it changes course and travels 80 miles on a bearing of 140 degrees, which is south 40 degrees east. I'm going to look at the difference between these like angles and say, okay, that's a 70-degree angle, right? Now, what direction is it going? Well, it's going south 40 degrees east. If we go south, we go 40 degrees, it looks like that, right? So we're going to take that angle and bring it up here. So we say, okay, that's 70, right? That's 140. We're saying, okay, 140 minus 70 equals 70 degrees. So that angle right there is 70 degrees. Okay, now we can just, then we'll have to put, okay, it travels 80 miles on that bearing. So that's 80 miles. All right. So there is our triangle. Now, what do we have to find? How far is the boat from the starting point? So this right here is our boat, and this is our starting point. Okay, so how far is the boat? Well, clearly this little X right here is how far the boat is. And then what is the bearing of the ship from the starting point? We can do that afterwards. Okay, so how far from the starting point? Well, we have this angle and we have two sides. All we can do with this is do the law of cosines, which is a squared equals b squared plus c squared minus 2bc cosine a. So this will be our like a squared because we have the angle right across from it. So this will be x squared equals 60 squared plus 80 squared minus 2 times 60 times 80 cosine 70. I'm just going to put that all in my calculator. So 60 squared plus 80 squared equals 10,000. 2 times 60 times 80 times cosine 70 equals 3,283. We do 10,000 minus like the 3,283. We get 6,100, well, 6,716. Then we'll just take the square root of that because we have to take the root of both sides. The root of that is 81.95, which is 82. X equals 82 miles if we're rounding to like the nearest tenth. Okay. So now that we have the distance, we are going to go to our second problem, which is what is the bearing of the ship from the starting point? We already know that we started at a north 70 degrees east line. So this angle right here is 70 degrees. So when bearing comes around, that angle is going to be important because we're going to have to add that to this angle theta here. Okay, so we have our 70 degrees. Now all we need to get is theta. What we need to do to find the bearing is do our 70 degrees, our original angle plus theta, our like angle in this triangle. That'll give us our bearing. Okay, so to find theta, we can do the law of sines. So sine 70 over 82 equals sine theta. Wait, never mind. I actually just remembered something. So when you're doing the law of sines, you first want to find the smallest angle you can. So clearly, theta is not going to be the smallest angle because it's like opposite from the like medium size side. So this angle over here, that's the opposite of 60, will be the smallest side. So we could just call that like y. All right, so sine 70 over 82 equals sine y over 60. So we do our little math. We do sine 70 and then times 60, cross multiply, divide by 82, and then we'll have to take the sine inverse of both sides. So sine -1 of that gives us 43.4. So y, like angle y, equals 43.4. Okay, that means theta equals 180 minus 70 minus 43.4. So we do 180 minus 70 minus 43.4, and that gives us theta is 66.6. Okay, so now we do our 66.6 theta plus 70 degrees. So if you add 70 to that, you will get 136.6. Now, if you're doing anything northeast, it has to be between 0 and 90 degrees. Now that we're at 136.6, that's over 90 degrees. So if you're doing anything south to east, this is 180 degrees, this is 90 degrees. So anything between those is southeast. 136 is between those. So now we have to say, okay, how far is 136.6 from like this south line, which is 180? So you could do 180 minus 136.6, and you will get 43.4, right? Like 43.4 degrees away from south and into the east direction. So it's south 43.4 degrees east is our bearing from, like, of the ship from the starting point. So wherever it says from, that's the theta you want. And then like to, of course, or like of, is where you want to go to. I hope this video was helpful, and thank you for watching.